I'm just going to say this one more time so that it's clear. Didymos and dimorphos are not going to hit the Earth. So with the success of NASA's DART mission, we're looking at a bit of a waiting period while astronomers on Earth observe Didymos for changes to dimorphos' orbit. But we need to talk about the images and video taken by LICIACube and Hubble, respectively, because this stuff is really interesting and it's causing me to speculate. Wow, I haven't heard that in a while. On what result we're going to be seeing in the coming weeks, months, and years. A day after NASA's DART mission concluded with a bang, with the $324 million spacecraft having crashed into Dimorphos on September 26 at 7:14 p.m. Eastern Standard Time, NASA released these striking images taken by LICIACube, the 6-unit CubeSat designed to follow DART and observe the results of the mission. Loyal science getters will know that we covered CubeSats in our last full DART video, which will be linked in the pinned comment for you to check out if you haven't already given that video a watch. But as a quick refresher, CubeSats are a class of miniature satellites that are packed with electronics and have super low mass. Seriously, CubeSats like LICIACube do not exceed 2 kilograms in weight, which is incredible. While LICIACube's images of the impact are certainly impressive, just look at that explosion. It looks almost like a plasma discharge, and it most likely is. We're going to be taking a look at some other telescopes that got some incredible time-lapse footage of this impact. When asteroids enter the Earth's atmosphere, they get super compressed. Their surfaces turn to plasma, and if they're on the smaller side, they will burn up before ever reaching the surface, and sometimes explode if they're a bolide. When DART slammed into Dimorphos, it was moving at the incredible speed of 6.437 kilometers per second. That's super fast. But to put that in perspective, that's 23,040 kilometers per hour. So when DART, a 19-meter wide spacecraft with a weight of 362 kilograms, slammed into Dimorphos' surface, which is 163 meters in diameter, it likely did turn a portion of the surface into plasma. And as an educated guess, I'd say that it likely did the same to the plasma surrounding the asteroid system as well, because as we all should know, 99.9% of space is plasma. Hubble also got a good look at the impact. Check out that shockwave. But even as impressive as this is, the James Webb Space Telescope did one better, and we'll get to that in the next section. This animation represents a time-lapse of images taken by the James Webb Space Telescope. It covers the time from just before impact and roughly 5 hours after DART made its dramatic finish. In this footage, we can clearly see plumes of super bright material surging from the impact point. It looks almost like a flaring star, with the impact point brightening quite rapidly. That's not it for Webb and the Didymos system though, as scientists plan to continue observing the system in the coming months using its mid-infrared instrument. They're also hoping that spectroscopic analysis will provide some much-needed insight into the asteroid's composition. But not to be outdone, Hubble had a few more surprises for us as well. In these images, taken 22 minutes, 5 hours, and 8.2 hours after the impact, we can clearly see ejecta flowing in an almost fan-like structure toward the right of the image. This is actually the direction that DART was coming from. Like Webb, there are plans to keep Hubble trained on the Didymos system as well. But this is where I want to get into some predictions. Just seeing how incredibly bright the images taken of the impact are from all of these telescopes gives me the impression that Dimorphos may be really porous after all, as one scientific paper suggested, which we covered in our last DART update video. Judging from these images and time-lapse videos and the size of that explosion, I think that Sabina D. Radicon and Martin Utzi's predictions were right. The goal of the double asteroid redirect test was and is to slow the asteroid down, thereby shrinking its orbit. As we train our telescopes on the sky to measure Dimorphos' orbit around Didymos, we will want to see that the asteroid is orbiting more often than it was before. This is a very small change, and you might ask why we're even doing this if we can make all the complex calculations leading up to DART's impact. After all, couldn't we just nuke it? And the answer to that is that space is complicated. Asteroids are complicated. So those calculations cannot account for all of the little things that could influence the outcome of a kinetic impact. One of the reasons why you would not want to nuke an asteroid is that it could very easily just clump right back together and still pose a threat. Thanks, Kyle Hill, for that extra bit of existential dread. I needed that this week. So this just in, NASA has come out and officially announced that DART was successful in changing Dimorphos' orbit. Before DART impacted with Dimorphos, it took 11 hours and 55 minutes to orbit Didymos. But now, post-kinetic impact, that orbit has shrunk by 30 minutes. Keep in mind that NASA's minimum for success was 73 seconds or more, and this exceeds that conservative benchmark by more than 25 times. I'll definitely be having a drink in DART's honor tonight. But taking the data from DART, we'll be able to extrapolate that and figure out how to scale our kinetic impactors so that they can alter the trajectory of much larger asteroids. And with that, I'd like to transition to easing the fears of many a commenter over the possibility that Dimorphos and Didymos could hit the Earth in the future. I've gotten a lot of comments over the last couple of months since putting out our DART videos, either asking if Didymos or Dimorphos were going to hit the Earth, or asking if there was a chance that the test could cause the asteroids to somehow hit the Earth at a future date. Neither scenario is likely to be a reality. These asteroids are over 10 million kilometers from the Earth. NASA and all of the partners involved with the project had and have zero doubt that DART's impact would only have a minuscule impact on the asteroid's orbit. So no, rest assured that Didymos and Dimorphos will not be hitting the Earth, possibly ever. They're just not a threat. But the reason why NASA and its collaborators chose Dimorphos was because of its size. It's at just the right size where even an object about the size of a car could alter its orbit if it were moving fast enough. I'm just going to say this one more time so that it's clear. Didymos and Dimorphos are not going to hit the Earth. The success of DART should be a moment for all of humanity to celebrate, because in the paraphrased words of Kyle Hill, who is definitely still worthy, it's the one natural disaster we can actually prevent. So instead of focusing on the anxiety that these space rocks represent to so many of us who have listened to fear-mongering media outlets berate us with clickbait news posts about near misses from objects that were anything but close to the Earth, focus on what this might mean for our species in the future. If you dug this short science video, be sure to do all that algorithmic jazz and check out our Discord and start up a conversation with science nerds like you. And hey, check out all those wonderful names. Thank you, patrons. I'm Eric Malachite, and I'll see you next time, Space Cowboy.